Alright, so today we're going to be looking at factoring trinomials again. However, we are looking at this idea of the difference of two squares, or perfect square trinomials. So I'm going to zoom in here for a second, and it's going all over the place. One of the things that we want to keep in mind when we look at these problems that we do today are for specific numbers. We're going to be looking for two squares or perfect squares. So we're going to be looking for numbers like 4, 9, 16, 25, 36. The reason these are perfect squares is because when we take the square root, we get a whole number. Okay, so like the square root of 9 is 3. The square root of 16 is 4. Okay, so that's what we're looking for. Or these numbers here, like 4, 9, 16, 25, 36, 49, 8 times 8 is 64, so we'll look for 64. But those are the types of things that we're going to look for when we look for the difference of two squares and perfect square trinomials, okay? I don't know why it's like awkwardly tilted. Okay, so let's go ahead and look at some of these practice problems. I'm going to do like maybe number 2 and number 3 with you. So I know a lot of you prefer the box, so let's go ahead and draw that box. Okay, so 5x minus 1, 5x plus 1. And just as a reminder, it doesn't matter where you put them on the outside of your box. Okay, you might have put your factors in two completely different places. That's all right. So 5 times 5 is 25. X times x is x squared. 5x times 1 is 5x. Negative 1 times 5x is negative 5. X and negative 1 times positive 1 is negative 1. When we combine like terms here, the first thing I notice is that this 5x and this 5x cancel each other out. So I'm left with 25x squared minus 1. That's my final answer. That's as small as I can make that thing go. Okay. And number 3, I'm going to draw that box again. Okay, so x plus y, x minus y, and we can go ahead and fill out our rows. Okay, so x times x is x squared, x times y is a positive xy, x times negative y is negative xy, and negative y times y is negative y squared. Okay, so we can go ahead and actually cross out the xy and the negative xy because they cancel out, and all we're left with is x squared minus y squared. Okay? Alright, so on our star reference page, on our EOC formula chart that we get to use, we're actually given this formula right here. A squared minus b squared is the same thing as a minus b times a plus b. This is the difference of two squares, okay? So when I'm given a factor, and I know that it's the difference of two squares because it's the same variable and it's the same letter, so as long as I'm given the same variables and the same b values here, a positive b and a negative b, one of the ways that we can shorten it up is by going like this, a squared minus b squared. So an example of that might be something like this. If I have x minus 2, x plus 2, this variable or this number right here is the exact same number. I'm given the same variables, and so to simplify this, we can do x squared. Oh, it took me a wow. Okay, so we can go x squared minus, what is 2 squared? If you don't know what 2 squared is, plug it into your calculator. 2 squared is 4. So that would be my answer, and that's a simplified way of going about it instead of having to do the box or the foil. Okay, Alright guys, looking here, it says factor completely, so now I'm going to break it down. Now we're going backwards. I know that 4 is a perfect square. It was one of those numbers that I asked you to keep in mind when we were looking for our problems. So I know that I can break this down into two things. Boom, 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 boom. We're going to have an x. We're going to have another x. If I go back to the slide before, I know that one of them is going to be a positive and one of them is going to be a negative. And no, it doesn't matter which one we use or what set of parentheses are in, or which sign is in the set of parentheses. So now we're going to take the square root of 4. Square root of 4 is 2. So I'm going to put a 2 here and a 2 here. And that's my final answer. And yes, it really is that easy. Okay? Oh, hey. Ooh. Factor completely, we're going to do it again. So, we're going to break it up. Minus, positive. Is this possible to factor? Now that I look at it, I think it is. No, it's not. This one's not even possible to factor. And the reason why is because if I follow this, the formula that was given, we have our x squared plus 16. The catch is that it's a plus. When we have the difference of two squares, that means we subtract. So because we subtract, we actually can't factor this. All because of that plus sign in the problem. X squared plus 16. We can't break it down, we can't factor it. Okay? Okay, now this one, we do have a subtraction sign, so I know that I can take the difference of two squares. So we're going to boom, 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 plus, minus. I know there's going to be an x and there's going to be an x. Now the catch is that we have a number in front of the x squared. That is the number 4, and 4 is a perfect square. The square root of, well, I just gave you the answer. The square root of 4 was 2, so I'm going to put a 2 in front of the x. And contrary to popular belief, the square root of 1 is a perfect square because it's just 1. So I'm going to put a plus 1 and a minus 1. There's my final answer. Okay, same idea, ladies and gentlemen. I see a minus sign, so I know that I can take the difference of two squares here. There is a small catch. We have a y squared. So I know that when I break this down into my parentheses, we'll have a plus, we'll have an x plus something y, and an x minus something y. So if I take the square root of 36, it gives me 6, so I'm going to put a 6 in front of the x's, and we're going to take the square root of 25, which is 5. So I'm going to put a 5 in front of the y's. Final answer. Okay. So we're given a few other things on our star reference page. And those look like this. These are perfect square trinomials. Okay? So if I'm given, and these work the same way as the other ones, a squared plus 2 times a times b plus b squared is going to equal a plus b squared. Okay? Same with a minus b squared. So when factored, the two binomials should be identical and can be written as a plus or minus b squared. So that means that when I'm done factoring, everything inside the parentheses should be the same. Okay? Keep this right here in mind. A squared plus 2ab plus b squared. Okay? So I'm going to actually zoom in, and I'm going to write them up here. A squared plus 2ab plus b squared equals a plus b squared. A squared minus 2ab minus b squared is a minus b squared. Okay. Now this one's going to be a little different. We actually have a subtraction sign here. And one of the things that we talked about, oh goodness, I'm going to sneeze. Okay. So one of the things that we're going to do, very first thing we're going to do is, I know this is a perfect square trinomial, first off because it tells me so, but if it's a perfect square, the very first thing I said when we started was that we're looking for perfect square roots. So I'm going to look at all of the numbers in front of the coefficient, or in front of the variables, the coefficients, and see if they're perfect squares. If I type in the square root of 18, it is not a perfect square. But if I type in the square root of 81, that is a perfect square. Okay, so I know that when I break this down, I know that my number is going to be 9 on the inside. The only problem is that the term on the inside, if you remember from our notes from Monday night, tells us a clue about what goes inside the parentheses. If my last term is positive, then whatever's inside the parentheses has to have the same sign as the middle term. So both of these inside the parentheses need to be minus signs. Perfect square trinomials tells me that everything inside the parentheses are the same. And in this case they are. So I'm going to rewrite this as x minus 9 squared because it is a perfect square. Okay? I broke it down into two factors that are exactly the same. Okay, so look at this one. Oh, wow. Okay, so I'm looking. 169. If I type in the square root of 26, it gives me some decimal and bad things happen. Okay? So we don't like the square root of 26. But if I type in the square root of 169, I get 13. So I know that when I break this down into two sets of parentheses, I'm going to get a plus, well, I don't know about plus yet. I know my number is going to be a 13. And remember, because it's positive, my parentheses are going to have the same sign as the middle sign, so it's plus. So when I go ahead and rewrite this, because it's a perfect square, we have an x plus 13 squared, and that's my final answer.